We have 15 minutes or so. All right, so let's go over a little bit of the end again. So the goal for these set of videos is more looking at, and there's a lot going on in here. This is what we um, did in class. I'm gonna sort of clean some of this up. So bear with me. One thing is, if you're making selections, like we can go to edit, select objects, and then select very certain type of objects. Um, so we can select curves and delete them all. So there's a couple ways of doing this. We also have a selection filter where we can say we just want to be able to select curves. So that way I just do that and I just get the curves. So I don't get surfaces. And what you guys are seeing here is it's a quick sort of way to sort of take this geometry and then figure out how to sort of flatten it. Okay? So let me just pause real quick. So if we look at this geometry, this is a project that I did, and it's all about sort of doubly curved surface geometry, and then how do we start to think about making these things, right? Or how do we think about them at as a larger scale, and then trying to produce an output that represents maybe the initial sort of geometry, but somehow is, in the end, is altered to make it feasible to be sort of constructed. So, in that sense, with the 3D print, right, we can take what we've been making and 3D print it, and we can easily do this. But like we've talked in the past, if you try to 3D print something at a really large scale, the technology is getting there. There's 3D printers that can print a room that's bigger than this, and they can extrude concrete. But I don't know if we want to live in like a concrete hut, like a really, right? So we looked at, we talked, maybe other architects like Frank Gehry, right? So Frank Gehry deals probably, if you guys look at the band shell, it's more about panelization, right? How do you panelize the curve, these doubly curved surfaces? If you look at Zaha Hadid, she's probably doing it closer to like using composites, using some type of substructure that's a skeleton, and then it's skinned in some type of fiberglass material, and then treated, and serious technique. So here we're looking at similar concepts of how do you sort of produce this out of sort of flattened material. And what we're doing is going from a geometry that's maybe doubly curved to geometry that's all polygonal, so it becomes made out of triangles, forcing it to be it's not curving, period, one or two directions. It's really faceted. And then going back and then thinking about how do we sort of recreate that out of a material that maybe is flexible. So this is going from this model, sort of changing the resolution of the model, of course, and making it look a lot different. And then going from that to maybe looking at materiality that can sort of start to replicate some of the curvature again. So if we take this and do this with it, these surfaces are basically all these specific sort of seam surfaces being created completely flat. So if we take this and start folding this stuff up and stitch it together, we'll basically get something that starts to look like this geometry, but it starts to act like this because um, we're not sort of scoring it or forcing it to be triangulated. We're letting the parts that are not triangulated to sort of flatten out and become curved. So these sort of segments disappear, but the key is the seam lengths are all the same. So this seams up perfect as we unskin it. Okay. So for what we're doing, you guys are going to take, your little dome sculpture, your structure, and then you're going to start to break it down and start to think about how do you sort of reassemble it in Rhino as a flattened surface. So what we're looking at here is, the structure I've been using. And what I've done is start to manually start to draw this. And I'm going to show you guys how to do that. Draw the sort of triangulated geometry. And then start to keep on doing that to the point where we start to develop all the patterns and then start to flatten those patterns. Similar to the way fashion works, right? So you saw, if you remember the stuff from, the concrete formwork, the fabric formwork, they're using fashion more than architecture in those techniques. Yeah, it's all about draping, it's all about seams. So we're going to look at it. For this exercise, the seams are going to just be generated dumb and probably not correct, but eventually we're going to start looking at seams. This project was all about seams, so it's sort of even like this was recreated based on understanding where seams were going to be. So like, how do you take a shirt off, take apart, right? Like there's certain areas where we want the seams to be. And eventually, if we start to let the computer sort of, or the software unravel it, sometimes it doesn't unseam it properly, so we do it manually. And then the last part of this is, once we get into Grasshopper, I'm going to give you guys this definition where we basically, so we're going to do it manually, and then I can go ahead and just give you a definition, and it's going to do it automatic for you. So here it is all unseen. And as we change the divisions, it sort of recreates it. So there's the new. So this is where the power of sort of Grasshopper, because Grasshopper is nothing different other than, just imagine you can record all your steps. Okay? That's the easiest way to explain it. And if we can record all our steps, there's critical parameters that we can change, right? That alters the end result. So by doing just a few sort of tweaks, maybe in how many to divide this by in one direction versus the other, it starts to change the output. Okay? It's that simple. All right? So you see it's sort of doing all the techniques, and then it's giving us the end result. Okay, guys, does this make sense? So let's not worry about this right now. And we're not even going to go through this. I'm just going to give it to you, and then you're going to go through it and try to understand it. But we're going to do it manually. So a lot of the things we're going to do first is manually, and then we're going to go and do it. Actually, I'm just going to copy this. I'm just doing an invert command and then a hide command here. So I just have this surface, right? So we did our rebuild, and we end up changing this 10 by 10. And that creates these iso curves. So you see these iso curves? If we go to properties, show surface iso curves, we can turn them on and off. So you guys have an idea. All right? And then what we're going to do is, again, extract the wireframe. And then I'm just gonna, sorry, I'm gonna hide that surface, so I type in hide again. And I just want the wireframe. Okay. Sometimes you get like confused of what's inside and out, but doesn't matter. Okay. Now I'm gonna start drawing the triangulated form. So I'm going to start, the reason I divided by 10 by 10 is because that becomes like my underlining structure for my snapping, okay? So I don't even need the surface anymore. All I need is sort of the wireframe. I want to go in here on O snap, make sure my settings are on, and then what I can do is, as soon as you trigger this, this appears here. You want to make sure intersection is on, and you can turn everything else off. So intersection. Then I'm going to go to surface, and we're going to use curve points. Surface, corner points. Sorry, not curve points. Corner points. And then the shortcut is, you can see, it's surf points. Yeah, I don't know. Corner points and the pull down, and then for the other. Does that make sense, guys? So what I'm going to do is just make triangles, and I want to be somewhat consistent. So it's like click once, click again, and click again. So I have 3 points, make a triangle, hit enter, that makes the surface. And I'm doing this manually. I don't have to be too careful that I do it in the same order. But typically if you boom, 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 enter, click, 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 spacebar. Spacebar activates it again. So I'm just using my thumb the whole time. So I can move pretty fast. And if you missed, redo it. So you can see where we're at. So we're going to keep on going here. So once we're done with that, we can take this, we can take these and join them. So we're going to use the join command. So if I join them, they become one surface. One thing we need to check, under Analyze, we can go to Direction. This shows us the direction of the surface. So surfaces have outside and inside, just like shirts do in garments, right? So people wear their stuff inside out, but a model can also have an inside out to it. So we want to make sure, in this case, our direction is actually pointed inward ultimately. Okay. The reason why is when we start unrolling this, which we're not gonna use smash. We're gonna use unroll. It's gonna make sure that it's not a we're not looking at the bottom side, we're looking at the top side, which for us is the outside. All right. We'll flip it later. We'll go over flipping. So it's not so critical right now, but in a little bit it will be. So I'm gonna keep on going. I'll pause this, and I'm gonna. So let's look at, so we've produced a lot more now. This has all been joined as one. So I've done these in strips, and I joined these in one. This one here, I've left the strips alone as individual. Okay? So this is where I want to analyze the direction now. We can see it's going inward, good. I want to check all these and make sure they're all going inward. If for some reason it's going in the wrong direction. So I check this and it's going in the wrong direction. Right? We can use the flip command and flip it inward. Okay? So F or flip. Now, if I take this one, and I'm going to use the command unroll, surf, I want to make sure explosion is no. We don't need label on. We'll look at label. Keep properties can be yes. We hit OK, and then it unrolls it. What happens here is when we let the software unroll it, it starts to sometimes unseam it a little bit strangely. So you can see now it starts to create fingers. This is like if we took it and smashed it, right? And if we smash it and we define where the seams are, and we know these are triangles, right? Because triangles can lay flat, it just unrolls. It's 100% perfect. There's no missing. Area difference is within tolerance. So that means there's basically zero growing or shrinking happening in the model. All right, so what we have in the digital model is going to be what's going to be in the outside model. Is that clear? Because that's really important in the architectural world. All right. So I don't like the way this is seen, so what we need to do then is think about unrolling parts of it. Okay. And then start to understand which parts go together. What I didn't do is turn on the labeling. So I'm going to turn on labeling now. I'm going to delete this. Maybe why. Okay. So yeah, this creates that odd seam. So if we do this, I'm going to do an unroll again. This time I'm going to say label yes. And what this does is it puts a bunch of numbers so we know what is what. So we know this is 25 up here. Okay. I'm going to unroll this one now. So we know this is 28 and that's 25. So it's always going to go 28, 25. So we know 28 goes with 25. $28 is here, goes to 25 there. So we can see something is, let's look at the direction of this. See how that's going out? So this got unrolled the wrong way per se. And I take it, and I guess it depends on how you want to look at it. In the end, it doesn't really matter, as long as they're all going the same way. So you see how those go in? So it's actually, let's redo this. And I think in the end, I take it back. I think we want it actually going out. So let's go ahead and unroll. Actually, we're going to flip this. Sorry, flip. So we're going to flip the, just by typing in flip, we flip the direction. You can check that to make sure. There it is. And let's flip that as well. So those are going both out now. So let's unroll this now. So 25, 28. So this looks better. So 25 goes to 28. So I use a orient command, O-R-I-E-N-T, orient. I select both of these. I click here and there, and then I click there and there. Okay, so these will always line up. So as we cut this all out, we can roll this out. Okay, and now I do the same thing on here, unroll. We know 25 goes to 28. Oops. Delete that. We don't need that anymore. So 28 here goes to 25 there, so I use an orient. Did I forget to flip this one? Let's check. Yep, I have it the wrong way. That's why it wasn't lining up. So if you see things not working, like, hey, it's not lining up, just double check your direction. Alright, so we want to flip it. Alright, so now we'll do an unroll. And we'll do an orient. So there we go. Okay, so that represents, if I take these away. For us to get rid of those, we got to ungroup all this. So we got to go to group, ungroup, edit, group, ungroup. Ungroup is like it's in a group, so we want to ungroup them. It's like they're in a band, yeah. Break the band apart. We have like multiple. I'm gonna select this. Just go ahead and invert it. Alright, so there's our final part. Then we're gonna use our so we can move these around where we want them. Then we're gonna go ahead and use our curve boolean command. Okay. So curve boolean. That's going to give us the outline. Hit enter. So in the end, we just need that pattern. Okay. If we cut this pattern out, we'll get it the great shape. We can also start to do other things too. So if we want to eliminate, we're not going to do this for this time. So what you guys need to do for next week is actually produce this off of your own. Okay. Divide it, wireframe it, triangulate it manually, think about unrolling it, how you want to unroll it, how you want to join it. You can also go this way, you can go that way. It's up to you. And then you're going to bring this in so we can, and have it printed so we can cut it out of 8.5 by 11. And then we're going to have fun foam that we're going to cut it out of. And then you're going to also print it out 11 by 17. And then we'll get bigger sheets of fun foam. So you need to bring in next week, as I think I mentioned many times, maybe, scissors and needle and thread, okay? Because we're going to stitch this together like a baseball, you know, to make that dome shape. Like 5 more minutes. The next part is looking at, so we did that manually. What we're going to do now, so if we look at the grasshopper definition, I'm going to upload this as well. This is a real simplification of the geometry, okay? So what the grasshopper definition does, it just takes one input, which is your surface. So we right click and we say set one surface, and then we pick it. And then it generates the output based off of that surface. Okay? Now we have some variables here. We can swap like how we're dividing it. So we're cutting it this way. So there's a swap command, and then we can increase. So if we did 10 by 10, this is exactly what I just did manually, all done for you. Okay. These A, B, and C are A, B, and C done for you. Like it unrolled it. When I spent that time making all those triangles, that's these guys unrolled. So what I can do, so I want you guys to do it both ways. I want you guys to do it manually, so you understand how to use Rhino. And then I want you guys to come in here and try the grasshopper definition. Boom, there it is. And then what you can do is go all the way to the end. That's them right there. If you right click that and bake the orient, just put them on. Oh, it must be off with them. There they are. Okay. And then you can start putting them together, like how they should go together. So you still have to put them together. I haven't made that part of the definition yet. That it like makes the full. You still have to spend time, you know, in doing that. And then understand where those are going. So you have to know your model a little bit, right? Then it's all working. It's not intersecting. At some point they might overlap, and that's where you create a new scene. You have to separate them completely. Right? Like there might be a time where they fall on top of each other, and then those, like you say, okay, this is going to be one patch, and this will be the next patch. Because that's going to probably, you know, this is really interesting because it's like folding on itself. So some of these will be trickier than others. Okay. Like I think once this will not fit, so I need to start taking. I think that I'm not even sure where that. You know, you got to. There's going to be some problems here because the way I did this one, because don't forget that thing like folds on itself here. So cutting it this way might be problematic. It might be better to go this way with it. So this is where we got to deal eventually. Like if we really want this geometry, we'll see what problems we run into. This is where we would actually recreate this as a seam here. And then cut all the inside out. Like whatever's getting wrapped. So we would have to, because it's intersecting itself, we'd have to cut that and make a seam. And then probably make this surface here as its own surface. And then we recreate it. So we can eventually start to, you know, we can try to create a, yeah, that's not going to work. We could do a couple things. We could start to create, you know, a curve on the surface, but we can also start to look at using projection techniques to project down there. So again, for next week, come in with these ready to go. The last step, again, would be the curve Boolean, right? To get the outline. So that's all we want. Okay? Okay, let's stop there.